Welcome to this third module on the review of high school algebra. The current one will be dealing with factoring. So what is factoring? Well, in simple words, it's the opposite of expanding. For example, if you have an expression like 2x squared plus x minus 15, you have what's called a trinomial, three terms, trinomial, that is not factored. But we're going to see if we can actually are able to write it as a product of two brackets. That would actually be the current factored form of the above expression. So there's all sorts of factoring. Let's start with simple factoring, which is really about taking out a common factor to all the terms that we have. The idea is to take out the terms, the variable with the lowest possible exponent on each variable. So for example, here between 2 and 10, I can take out 2. I have x3 and x2. I will take the one with the smallest exponent. I will take it out. That is x squared. Between y5 and y4, the smallest exponent is y4. And z4 and z, I can take out z to the 1. So the idea is now to actually fill in this bracket with this term, call it star 1 and star 2. And how do we find this? Super simple. We take for star 1, we take the term that is, well, the first term, and we basically divide it by the common factor, and we let the rules of exponents do the rest. So the 2's cancel. x3 over x2 is x1. y5 over y4 is y1. And z4 over z is z3. And that's the term that we're going to put here, xy z3. As for star 2, we do the same thing, except we actually take minus 10 x2y4z divided by the common term, what we have factored out, 2x squared y4z, and well, a lot of cancellation, x squared, y4, z1, z1, minus 5 is all that's left, so minus 5, the minus is already taken care of here, so that the final answer for this problem is just very simply this, 2x squared y4z bracket xyz3 minus 5. That's the idea behind simple factoring. Okay, here's another one that we're going to meet also in calculus. We want to factor out whatever is common between this half and this half, which are separated by a negative sign. So I can see here an x squared and an x1, so I'm going to pull out an x to the 1. And here I have an x plus 1 to the 1 half and an x plus 1 to the 3 halves. Again, the idea, take out the common term with the lowest exponent. So here we go again, star 1 and star 2. And how do we find those guys? Again, same procedure as before. Take the first term and divide it by what you have chosen to pull out. What's the outcome here? X squared over x is x, and those two are gone. So that is star 1. Star 2, so minus x, x plus 1 to the 3 halves, over x plus 1 to the 1 half, This time the x's go away, and we find ourselves with x plus 1 to the 3/2 minus a half, again by the rules of exponents, and that's minus x plus 1 to the 2/2, or just 1. So that's minus x plus 1. So what's the final answer to this problem? x plus 1 to the 1/2, open bracket. Let me take the minus inside the bracket, so minus x minus 1. So that gives me x plus 1 to the 1/2 times the x's cancel out. And here's one way to write the answer, minus x times x plus 1 to the 1/2. And here's another way to write the same answer, minus x root of x plus 1. Both are considered full marks. So that's simple factoring for you. Now, double factoring is simple factoring twice. It actually applies when you have 4 terms, sometimes more, and you can actually factor out the first 2 terms separately from the last 2 terms. If a common factor turns out, then we can refactor it, and we have a nicer expression to work with. So what can I factor out of 2x3 minus 6x2? I can certainly factor out 2 and x2. So how do I get my inside of the bracket here? 2x3 divided by 2x2, that's x. 6x2 divided by 2x2 is 3 with a minus. Good. What can I factor out? Minus x plus 3. Not much really, perhaps only minus 1. And if I do so, if I factor out minus 1 from minus x plus 3, guess what? I will get x minus 3. Same term. I can refactor out. This is why it's called double factoring. I'm refactoring this. And what do I have left? 2x squared minus 1. And that's it. Simple as that. It's your final answer for the double factoring. Difference of squares. And again, an old formula from high school. A squared minus b squared. That is a plus b times a minus b. So to factor out 16x4 minus 9y6, first, I'm going to actually establish that I really have a square minus a square. Again, those rules of exponents, huh? They're everywhere. So 16x4, that's the square of what? Oh, it's a square of 4x2, isn't it? Because 4 squared is 16, and x squared is x4. Let's do the same thing with the 9y6. What's this the square of? Well, the square root of 9 is 3, and the square root of y6 is y3. One can verify that 3 squared is 9, and y cubed squared is y6. So now I really have a difference of squares where this is my a, and this is my b. And all I got to do now is apply the formula a plus b times a minus b. So that takes me where? That takes me 4x squared plus 3y cubed. And the same thing with the minus 4x squared minus 3y cubed. C'est tout. That's it. That's all. Final answer. Difference of squares. Easy stuff. General trinomials. Ax squared plus bx plus c. This is the famous product sum method. So when we have 3 terms, we multiply the a and the c to give you a product of minus 40. And then the b term is the sum of the 2 numbers you are looking for. So just to summarize, now you want 2 numbers whose product is minus 40 and whose sum is 3. Why don't we list the factors of minus 40? What are they? Well, let's drop the sign for now. 40 times 1, that's 40. So is 20 times 2. So is what? 10 times 4. So is 8 times 5. Uh-oh, I think I got a winner. Because there is no way to combine 40 and 1, 20 and 2, 10 and 4 into a sum of 3, no matter how you play with the signs. But if you put plus 8 and minus 5, then you have plus 3. And that's the middle term b. So these are the two numbers that we actually want. And what is it that we do with these two numbers? We actually simply replace the middle term. So 10x squared minus 4. And we replace the 3x with 8x minus 5x. What is that equal to? Well, still some work is needed. Double factoring is the key. So what's common between 10x squared and 8x? Well, 10 and 8, you can take out a 2. X squared and x, you can take out an x. You will get 5x plus 4. Now, what do you think we should factor out of minus 5x minus 4? If you answered minus 1, you have a good instinct for these problems, because if you do so, you'll have again 5x plus 4. Since 5x plus 4 is there twice, we can actually refactor it. 5x plus 4 as a common factor, and times 2x minus 1. And this is an easy way to factor out trinomials. The larger the a and the b and the c, then the better the product sum method is. When the numbers are small, you can always try, well, trial and error. That will certainly work. But when the numbers are big, having a bit of a method is of a great help. Sum and difference of cubes, two formulae that some of us have seen in high school and some of us have not. A cube minus b cube is this guy. A cube plus b cube is that guy. So let's see how we apply that. Factor completely the following expression: 8x3 minus 27y6. This is supposed to be the cube of something minus the cube of something else. So 8x cubed, that is what? The same thing as 2x cubed, because 2 cubed is 8, and x to the 3 is obviously x to the 3. Now, what about 27? What's the cube root of 27? Oh, it's 3. And what is the cube root of y6? Oh, it's y squared. One can verify that 3 cubed is 27. Y squared to the 3 is y6. And that is now your A. That is now your B. So you apply the formula A minus B. You apply the formula A minus B times A squared plus AB plus B squared. And you are going to get 2x minus 3y squared times a squared. So 2x all squared. That's got to be 4x squared. Plus AB, the product of the two. So 2x times 3y squared. That would be 6xy squared. Plus b squared, so that's now the square of 3y squared. That is 9y4. And that product, should you decide to expand it, that product would actually give you, after simplification, 8x3 minus 27y6. Here's another one. x4y squared plus 8xy5. This time, I don't have a perfect cube. X4y squared is not the cube of anything in particular. Perhaps if we do simple factoring on this first, we'll uncover something more interesting. So what can I factor out from x4 and x1? Well, the smallest exponent is the ticket, and y2 and y5 take out a y2. What is left? x3 plus 8y3. And that so happens to be what? That so happens to be x all cube plus 2y all cube. So that is the sum of two cubes on which I will apply the formula that I know. A3 plus B3, that is A plus B, times A squared minus x times 2y, so 2xy, plus 2y all squared, 4y squared. And that is the final answer to this guy. Finally, one summative example, something that's going to bring together more than one type of factoring. So notice that the plus sign is here, creating really two terms. Our job is to see what's common, first of all, to these two terms. We don't want to expand all this because then it's going to be very messy and very difficult to refactor. What we want to do on this is simple factoring. So what's common to 2 and 8? 2. What's common to x minus 3 and x minus 3 squared? X minus 3. And what's common to 4x plus 7 squared and 4x plus 7? Always choose the smallest exponent to the 1. What is left? Well, once again, perhaps it will be easier if we do the star 1, star 2 method. So how do I find what is in this bracket? Simple. You take the first term and you divide it by basically what you have decided as your common factor. So much cancellation here. Gone, 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 gone. 4x plus 7 to the 2 over 4x plus 7 to the 1. That's 4x plus 7. That is your star 1. How does one get star 2? One gets the second term. And one divides it by the common term, 2 times x minus 3, 4x plus 7. Bye. 8 and 2 is 4. And x minus 3 squared over x minus 3 is just 4 times x minus 3. This is your star 2. So our final answer is going to start to look like this. Open bracket, star 1, 4x plus 7, plus star 2, 4 times x minus 3. Perhaps we can expand what's in the square bracket and collect like terms to make it look a little better. So what do we got here? 4x plus 7 plus 4x minus 12. Final answer. Final answer. 4x plus 7, 8x minus 5. And that is the final answer to this summative problem. Hopefully this was useful in reviewing the techniques of factoring. This will be important when we tackle the first chapter of the course on limits. I wish you